Hi again. Let's make some numbers out of this phenomenon of the exposure. That's how your camera talks back to you, is with numbers. And now that we've seen the way it works with water and little sensors, or big sensors, um, let's see how it looks to your camera and to the interface between you and your camera. And again, this is going to be more a factor if you are working with a DSLR camera, where you can control specifically the aperture, shutter speed, and sensor sensitivity, than it will be if you're using a point and shoot. But inside your point and shoot, the camera is doing the same thing. And this is going to be an issue with both DSLRs and point and shoots if you put your DSLR on auto. So let's see how this all looks in numbers. First thing you've got is light. What are the four elements of exposure? Well, let's start with light. Light. Then we have the sensitivity. How much light does your sensor, or in the old days, film, need? We're going to call that the ISO, sensitivity. How much light do we need to make an exposure? Too much light, overexposed. Too little light, underexposed. Neither of which are good, even if you can fix them in Photoshop. Then we have the size of the aperture, the size of the hole. What's the flow rate of the light coming into our camera? Aperture. Hole. Flow. Then, how long is the aperture going to be open? The shutter. Time. How long is our light coming into our camera? So aperture, let's call that flow. Flow. Light, sensitivity, how much light do we need? Aperture, flow rate, shutter, time. One changes, the other or another must change. You can't simply change one arbitrarily. You can't change it because it feels like you need to use an f16 or a 125th of a second. Your camera doesn't care how you feel. You need to analyze. This is physics. This is pretty quantifiable. This is not emotion. So I have a question. Where did this ISO number come from? It's a number. And I'm going to briefly go back to George Eastman, the founder of Kodak. And he would take his new film to the American Standards Association. They'd do a test. They would take a bunch of exposures and out in the sunlight using 125th of a second, or I'm sorry, using f16, size of the aperture. And they would shoot from 1 second to 250th of a second, whichever shutter speed was the correct exposure would become the ISO. For instance, f16 is the size of the hole, aperture, and the best exposure happened to be in sunlight at 125th of a second. Well, the cool thing about that is that the 125 happened to be the number they used for the ASA sensitivity. ISO people came and took the same numbers and used them also. So let's start there. We've got a bright sunny day. Our sensor sensitivity, ISO, is set at 125. 125 ISO. I happen to know the proper exposure for the aperture and shutter speed. If it's sunlight and your sensitivity is set at 125, your aperture is f16, kind of a small hole, and your shutter speed is 125th of a second. Now notice these numbers are both denominators of a fraction. It's f over 16 and 1 over 125. So as with cutting up a pie, the 1/4 piece of pie is smaller than the 1/2 piece of pie. Half a piece of pie, 1 over 2 piece of pie is bigger. 1 over 4 piece of pie is smaller. 1 over 16 piece of pie, you're going, how come I'm getting the little one? So anyway, these numbers are a little bit through the looking glass. They're going to seem backwards at first, but you'll get used to it. So this is a correct exposure for sunlight, for ISO of 125. That's what I've got my sensor setting at. F16, size of the hole, and 125th of a second, how long that hole is open, letting light in. Now here's something really cool. I can also, I'm photographing a galloping horse, let's say, and I happen to know from the last time I tried to do this that 125th of a second shutter speed is a little bit too long. Particularly the feet of the horse are blurry. There's things that are kind of fuzzy. I want that horse to look as sharp as I possibly can. So in order to stop the blur, I'm going to have to shorten the shutter speed. I'm going to leave my ISO at 125. I'm going to change my shutter speed to half as long. 1/250th of a second is half as long. Now, in order to get away with that, I am going to have to make the flow rate, the aperture, twice as large for half as long. That number happens to be f11. f11 is twice as big a hole as f16, half as long, 250, half as long as 125th, same ISO, same light. Boom, I am going to get the same exposure in each of these combinations, and therefore I will simply be able to stop the horse's movement and yet still get a good exposure because I've opened the aperture bigger. Now, let's say I'm doing a motorcycle and I want those wheels to be sharp. I don't want them to look blurry. That's going to be pretty fast. Well, let's do it again. 1/500th of a second. Bigger hole, F8. Same. The sunlight didn't change. The ISO sensitivity did not change. The aperture went bigger. The time went smaller. Same exposure. Oh, there's an animal that moves so fast. You need a shutter speed of 1/1000th of a second. No, it's not a cheetah or a jaguar. It's a hummingbird. But in order to use the 1/1000th of a second, I have to use an even bigger aperture. Bigger hole, shorter time. Same. It all comes out right. Only now, at a 1/1000th of a second, that's a very short time. That hummingbird's wings are frozen in time and space. Absolutely sharp. This is amazing. There was a guy who invented a camera that would do 1/1000th of a second just because he was a birder and wanted to see those little hummingbird wings frozen in time. Why would I not use 1/1000th of a second always? Here's briefly. I used to be able to read the dates on coins, no problem, when I was younger. But as I get older, my lens, which is inside your eyeball, which works like this, unlike moving it back and forth, it stretches and then it boing. When it's stretched, you can see far away. When it boings, you see closer. Well, mine doesn't boing quite as much anymore. So I can't see things that are like close. I have to back up and read them far away. You've probably seen old people do this. The thing is, I can take the New York Times out on the back porch here on a sunny day, and I can read it just fine. It's a small type. Why? My aperture, my pupil, gets smaller in the sunlight, and that gives me what's called greater depth of focus. In other words, even though my lens is still focused at arm's length, say, it appears sharper because my aperture is smaller. I'm not going to go into much depth on this because we've only got 5 minutes left. But that's why using f16 has advantages, because it's going to have greater depth of focus. You may be focused at 5 feet, but things at 3 feet and things at 9 feet are also going to appear sharp. They're not what you would call in focus, but they're sharp. Subtle, but bear in mind, f16, smaller aperture, has advantages that f5.6 doesn't. 1,000th of a second has advantages that 125th of a second doesn't. It's always what you call a no free lunch. So bear in mind, these things all relate one to the other. Now you can change your ISO sensitivity and then be able to use a shorter shutter speed or a smaller aperture, but the no free lunch factor there is that you start to get what's called pixelation. The little tiny pixels have to be made a little bit bigger, and as they get bigger, they get chunkier, and your refinement, your sharpness, your tonality just starts to lose its edge. And sometimes you get what's called noise. So, which is just random dots. So these things all have their relationships one to the other. We'll talk more about this as we go along, and it will become more a matter of nature. It's not terribly complex. Sensitivity, low is better for quality. High is better for being able to capture things in low light. Last night I was using ISO 800 at a wedding because the sun was going down, and I really would rather be in focus and being able to make the shots than to be able to not make the shots. So I changed my ISO to 800. That allowed me to use a smaller aperture and a little bit shorter shutter speed so that people wouldn't blur as they moved. Okay, so how does this look? We have a light meter in our cameras. A light meter is a most amazing thing because it does something your eyeballs don't. Your eyes read light, but they really don't quantify it because your ISO continually changes. Your retina can switch between rods and cones and be able to change its sensitivity. Your aperture opens and closes automatically. You don't know what it is. And plus your brain is pretty good at interpreting data even if it's not perfect. This, however, is a light meter. This is a marvelous piece of machinery, a Gossen Luna Pro. This is actually mid-70s technology. These are still around, and I still find these things for less than $25. I buy them at yard sales for like $5. It's made like an old Mercedes. It will give you a light reading. We're not going to go into too much depth on this, but it will allow you to meter more directly than your camera. Your camera is going to tend to tell you answers that this thing will tell you why the answer is so. Okay, your light meter in your camera. If you aim your light meter at something white, it will make that exposure so that the white thing comes out gray. You may have noticed this in your phone camera. If you aim this light meter at something black, it will give you the proper exposure. Notice that, look at that. It'll give you the proper exposure to make it come out gray. If the whiteboard comes out gray, I get very dark. If this dark thing comes out gray, I look like a ghost. So aim your light meter at something in between white and black. This is called a gray card. It's right in the middle of the scale between white and black. And if you aim your light meter at this and try to exclude anything else from having an effect on your meter, and it gives you a reading, gives you an aperture shutter speed combination at your ISO. If you make an exposure based upon that aperture and shutter speed reading, the gray card comes out gray, I come out fabulous. Does that make sense? So what you want to do when you're metering is to find something in the middle. Let's very quickly go through this. Oh, I'm not going to make it. We may have to start this again. We'll do the Aunt Martha in a minute. All right. Thank you.